I'm going to talk about tool compensation, and it's a little bit counterintuitive in terms of how the offsetting works, and so I just thought I would explain it a little bit to just to see if it makes sense. So let's say I've got geometry like this, and I'm going to create routing offset, and in this case I'm going to do an internal routing offset. Works basically the same thing with external, but the example I saw was with an internal offset, so I'm going to use that. And I've got both inside corners and outside corners, so we can see how that works with offsetting. And I'm not going to create routing offsets, I'm going to just create offsets, and we'll talk about them as if they're routing offsets so that we can offset them in both directions, which is basically what happens with tool compensation. So I've got this selected, and I'm going to do an offset, and let's use a bigger offset amount, and I'm going to offset it internally. And you see that if I do it rounded or square, it doesn't really affect the internal corners. In this case, it only affects what's offsetting as outside corners. But what you'll also see is that ultimately it doesn't make much difference in terms of what the final toolpath might look like, or particularly what the final part will look like when it's cut. So I'm going to do a let's say I'm going to do a square offset, which represents the routing offset, and I click apply to that. So now that's the toolpath that would have been created with the offset, and in this case with a square offset. So with tool compensation, typically what happens is we then want to offset from this toolpath back towards the geometry, and so because at the machine level, then it's going to be the tool compensation is going to then offset again back towards the toolpath, so that it gets to the toolpath that's needed for cutting the part out. It's a pretty good illustration of why there's a downside to this, because there's kind of offsetting in both directions, and it sort of opens things up for interpretation and all of that, both within and route, and also at the machine or with the machine controller. So our recommendation is to avoid the need for tool compensation, but there are times when it's important, and then based on how the machine works, that's the type of tool compensation that gets used. So in this case now, if en route is asked to do the tool compensation where we actually offset the geometry, essentially what happens is we go by that same amount, by the tool diameter amount, back out towards the geometry, and it does it using the rounded option, because that's the way that en route is going to offset that geometry back out to offset the toolpath back out to the geometry. So then when I click apply, now this, and I'll move it here just for a second, this is the geometry then that would get sent back out to the machine. And so if I move it back into position, then the idea is that the machine then would use the diameter of the tool that's specified in order to get back to the tool path that would cut the part out. So assuming that the part is or that the diameter is the same, then it would offset that back again, and it could do it either rounded or squared, depending on how it does its work. But then ultimately the part that gets cut out, which was our original geometry, is going to be the same. So it's then up to the machine controller as to what type of offsetting it does, but then ultimately, because this radius matches the tool's radius, I'm still going to get the square corner at the inside corner here, and I'm still going to have a tool radius here, which is based on the tool radius, based on this tool path, just like I would have if I used en route's offset. whether it was a square offset or a round offset. So that's up to the machine controller at that point. And so if I click apply, so now, oops, if I click apply, then this is what I would expect the toolpath to be that the machine actually cuts. This is what gets sent out to the machine for the tool compensation. And so you see that there's a lot of offsetting in both directions that ultimately, in theory, gets you back to a toolpath that looks basically the same as the original toolpath that EnRoute created. The difference maybe being that because of different actual diameters of tools and everything, that the tool compensation serves a purpose in order to compensate for a slightly different radius of tool or something like that is needed, that sort of justifies the tool compensation. So the question then is what do I expect to see in the output? And in this case, regardless of whether my initial routing offset was square or round, I'm going to get rid of that one. This being the initial, in this case, square offset, this is the geometry that I would expect to see output to the machine using the tool compensation option that tells EnRoute to offset like that. There's some tool compensation options that don't actually require an offset, but for the ones that do, that's what I would expect to see out at the machine for the geometry that gets sent to the machine, which will then be offset again by the machine. So anyway, a little bit confusing, but hopefully that helps to sort of illustrate kind of what I would expect to see with the tool compensation option that offsets from the toolpath back towards the geometry. One question that often comes up or might come up is, why don't I just use the geometry? Why don't I just use the original geometry that gets offset? And that's a fair question. The reason for that, and let's just draw another, let's say we've got a hole there. The reason for that is that the toolpath won't necessarily, the original geometry isn't necessarily a good representation of the toolpath that wants to get cut. So if I were to offset this, and again I offset it to the inside, and I could be round or square, it doesn't make too much difference. But when I offset that by the tool diameter, you can see that the toolpath is actually quite different than the original geometry. And so then if I offset that again back towards the original geometry, you see that the offset that I get is actually quite different than the original geometry because of the way that the toolpath and the diameter of the tool affected how the toolpath got created. So using the original geometry very likely isn't a good representation of what the toolpath wants to look like, that then would get sent out to the machine. And yes, it would get offset again, but it would get offset back towards the toolpath, which should then pretty closely replicate what the EnRoute toolpath would be that we created when we did the offset for the toolpath offset for the toolpath from the original geometry. So that's why using just the original, in this case, the original geometry like this isn't a good representation of what we want the toolpath to look like. And so that's why I don't use just the original geometry that I would then send out to the machine. So hopefully that helps, and if there's any questions, please let me know.